students. Today we are starting the new lesson, that is lesson number 12, Introduction to Acid and Base. So first of all, here some questions are given. Can you tell questions are there? So here we consume many food items. Yes, we are taking so many food items in a day. So inside it, in our daily life, inside it lemon we are taking, tamarind, tomato, sugar, vinegar, salt, etc. Okay. Do all atoms taste similar? Yes or no? No, because lemon is sour in taste, tamarind is also sour in taste. Afterwards, the next tomato, its taste is different, sugar is sweet, vinegar is taste, salt is salty. Means these atoms tastes are different from one another. Next, write the taste of lemon. Lemon is sour, sugar is sweet, curd sour, lime it is means that lime means, so now we are saying it is that baking soda, how is it taste, that you have to write. Amla, tamarind, raw mango. Okay, so because the mango after ripening its taste is sweet, but raw mango is sour in taste. Pomegranate, water, then sour, astringent, sweet, bitter and tasteless, these are there. So water is tasteless, sugar is sweet, raw mango is sour in taste, and the baking soda and all the lime are there, this taste is astringent in a astringent. So first of all, acid we will see. You will notice that some substances have, okay, now above activity we seen inside it, some taste substances have sweet taste, some are bitter, some are sour or astringent. Lemon, tamarind, vinegar or amla like substances acquire sour taste due to presence of typical compound in them. Okay, and such a compound imparting sour taste are called as acids. Means if the taste of a substance that we are eating in our daily life, if it is sour, then the given substance is acidic in nature. Means the curd, raw mango, then tamarind, lemon, then citric fruits like santri and all, oranges, these are which taste, these are having acids. Tomato, acids are soluble in water. You know that acids are there, they are soluble in water and they are corrosive in nature. Okay, if lemon juice if we put on our skin for some time, you will notice that that part is itching. Why? Because it is a property of acid, they are corrosive in nature. Animals and plant also possesses acid in them. Okay, you know that in our stomach also the hydrochloric acid is there, okay, for the digestion of food. Okay, so it is very strong, but in our stomach bile also secreting, and what happens because of it, the food becomes neutral again. Okay, acid present in foodstuffs are called as a natural acids. That is important. Acids which are present in our foodstuff like tamarind, otherwise lemon, otherwise curd inside, these are called as the organic acids or the natural acids. These acids being weak in nature, these acids being weak in nature, okay, actually acids are very strong, but these acids are there, they're weak, and that's why we are eating. Okay, so otherwise what happens, acids have the capacity to burn the substances too. Some acids are strong in nature, okay, and that's why we are not going to take the taste of which is unknown acids. They are caustic or inflammatory. Okay, for example sulfuric acid, that is H2SO4, sulfuric acid H2SO4, you have to learn these formulas today. Sulfuric acid, its formula is H2SO4. Hydrochloric acid HCl, then nitric acid HNO3. Okay, so these acids are there, are also called as a mineral acids. Okay, and they are very strong in nature. The skin gets burned when if by mistake these acids fall on our body, then what happens, it burns, the skin burns, their concentration of solution, concentrated solution falls on the skin. If such a concentrated solution is fall on our skin, then what happens, our skin burns. Okay, or any paper, otherwise any organic material burns when it falls on that substance. Similarly, the vapors of inhaled can harmful to the health. Okay, if you open the hydrochloric acids bottle, you will notice that some kind of vapors are coming out from that acids. Okay, and these acids are very concentrated, and if you are taking such a vapors in your respiratory, if you inhale, it is very dangerous to our health. Strong concentrated acids, I am speaking about the strong acids, not lemon. Inside it also acids are there, but they are very weak in nature and they are eatable. Strong concentrated acids are converted into their dilute acids by slowly adding them into the water. Okay, we have to add what, as slowly we have to add the water, adding water. They are making strong concentrated acids, we can make dilute one. Okay, means it's aqueous solution. Such a dilute acids are less harmful. Okay, such a dilute acids are less harmful than the corresponding strong acids. Okay, so that is general information about the acids. Okay, acids are sour in taste. Some acids are very weak that we are eating, but some acids are very strong, like sulfuric acid, hydrochloric acid, and the nitric acid. And these acids are called as a mineral acids, and by mistake if it falls on our skin, then our skin burns. The next part is the, if you taste a dilute solution of baking soda, if you taste a dilute solution of baking soda, so you will notice that how is its taste. It is astringent or bitter in taste. Okay, its taste is different. You just take baking soda and you just take the taste of it. Okay, you will notice that it is astringent or bitter in taste. Substances having astringent or bitter taste and slippery to touch, smooth, they are slippery to touch, then these are called as a bases. These are called as a bases. Lime water, that is calcium hydroxide is its scientific name. Calcium hydroxide means only lime water, CaOH2. This formula also you have to learn that I have underlined here. Baking soda, that is sodium hydrogen carbon. So NaHCO3, that is called as baking soda. Caustic soda, that is NaOH, sodium hydroxide. These are, and soap, that soap we are using to take a bath or the washing cloth, they are called as a bases. Okay, and bases are completely different from acids. The bases are completely different from acids. Chemically, they have properties opposite to that of the acids. Their properties are totally different that of the acids. They are also inflammatory to the skin and their concentrated form. We know that the distilled water is tasteless. Distilled water is tasteless. Water is neither acidic or nor basic, means it is which neutral one. If it is not acidic, if it is not basic, it is neutral. Okay, so from this what we are understanding, the acids are strong, they are astringent, they are sour in taste, bases are bitter or astringent in taste. Okay, and there if you see the main in the formula, hydrogen is main in the acids formula and base formula is there. Formulas are there, basic compounds are there. Here OH is there. OH is there. So that is about the little bit information about the bases. Now next part is the indicator. What are indicators? As we've seen that some substances are acidic and some substances are basic one, but to how to identify the given substances acidic or basic without taking taste and all. So for that we are using some substances, and these substances are called as indicators. Indicators. If you see sometimes that your suppose the turmeric powder falls on your clothes, and when you are washing it with the soap, you will notice that the color turns to red. Actually the turmeric powder is yellow in color. Okay, but when you are adding the base, then what happens, it turns red. Okay, so the turmeric powder is an indicator in which what happens, bases shows the red in bases shows a red color. Next part is the, so here this is the indicator. In that way some natural indicators are there. Okay, and that we are studying now. Some substances which are neither acidic nor basic and are chemically inert in nature. Inert, they are not showing any kind of a result with the acids and bases. Okay, touching or tasting of acid and base is very harmful, and the typical indicators are used to recognize them. Okay, so just now I told you the acid and base both are, we don't, means it is very risky to take the test of these substances. So how to find out the given substance is acid or base? So for that we are using the indicators, are, and these they have the particular color in that substances, and by using it what happens, we can identify that the given substance is acidic or basic one. The substances which change their color in presence of acid or base is called as a indicator. So that is the exact definition of the indicators. What? The substances which change their color in presence of acid or base are called as a indicators. Next part is the indicators in the laboratory. In our lab also some indicators are there, and these are litmus paper, red litmus paper and blue litmus papers are there, and litmus solutions are also there in our lab. So here we see indicators in the laboratory. In the laboratory, litmus paper is mainly used to take alkali or the base, to check whether the given substance is acidic or basic. We are using the litmus paper for that purpose. This paper is made up of extract of lichen plant. Which plant? The lichen plant is there. By using that plant's juice, what happens? These papers are prepared. It is red or blue colored. These papers are there, red colored or otherwise blue colored papers are there. Blue litmus paper turns red by dipping into acid. Suppose this is the blue litmus paper, and here it is red litmus paper. Okay, so this red litmus paper is there, and here it is, suppose blue litmus paper is there. Actually this much blue, dark blue is not there, but if these two are litmus paper, okay, this is red one and that is blue one, then it shows the particular it indicates the different sign. If this, what they told you, blue litmus paper turns red, if this blue litmus paper is there, if we put in the acidic solution, then this turns to red. This part, how much part you are dipping inside that acid, it turns a red in color. Where? In the acid inside the blue litmus paper turns red, and base inside the red litmus paper turns blue. In base inside, what happens? If base is, basic solution is there, then red litmus, what happens? Turns to blue. Okay, so here it is, red litmus turns blue in the alkali means only the base. Okay, and red will remain red in acid, and blue will remain blue in the acids. Actually this process is there. Similarly, with this litmus paper, there are some indicators, which are those phenolphthalein indicator. What? Phenolphthalein indicator is there. Methyl orange, methyl red are used in the lab. Means these are the solutions. How our water is there, otherwise in that way these are also solutions. They have the color. Methyl orange is orange color, methyl red color, phenolphthalein has a pink color. So these indicators are there, we are using to test the whether the substance is a acidic or basic. From methyl orange indicator becomes pink in acid. Methyl orange is there. If we add methyl orange in the where acid, the acidic solution turns pink in color. Okay, that you have to learn. And yellow in alkali. Alkali inside, if we are adding the methyl, suppose this is the beaker, here if it is acid is there, and if you add the phenolphthalein indicator, it turns pink color. And in base inside, if you add the base, suppose we are taking a soap solution, and inside it if we add the phenolphthalein indicator, it turns yellow in color. Then phenolphthalein remains colorless. Methyl orange I told you, na. Next it is the, if phenolphthalein indicator is there, remains colorless in acid and becomes pink in alkali. Same thing, if we add the phenolphthalein indicator in the acid, it remains colorless, means there is no color, and it becomes pink in alkali. One more the indicator is there, and that indicator is called as a universal indicator, which are liquid state, change their color in presence of acids and bases. Okay, actually it is liquid in color. We have universal indicator is also in our home, in our school, and by using this we are using identify the acids and bases. So here it is given methyl orange, it is orange color, you can see here. The next phenolphthalein indicator is there. These are there in our lab when you will come in school. I will show you this all. After this, methyl red is there. Its color is red in color. And here litmus papers are there. Just now I have shown you. These we are using our laboratory for identification of the acids and the bases. Okay. So all of you today read this part. This is very important and interesting lesson actually. And after this you have to learn these all formulas. These also, and that indicators all the colors changing, phenolphthalein inside and all that you have to learn. And this also you have to learn the formula, lime waters, baking soda and the caustic soda. These all formulas also you have to learn. So today we will stop here only. Okay, thank you and have a good day.